Yes, welcome back, members, to our YouTube channel. This is Math in Motion, and Shaka Anwar is your presenter today. I think you're all right. Welcome back to this edition. Today, we also have a sample question about national accounting and income analysis. Today, we're going to do a sample question. As you see on the blackboard, we have state the key assumptions underlying the input-output analysis, given an inverse coefficient matrix, and they want us to give the logical meaning of each of the leading diagonal elements, and they have given us the final demand. They want us to compute the output, gross output. Likewise, they told us there's an increase in the budgets, the final budgets. They want us to find out the change in output levels. But members, before we do this, I think you've got this question, but I want to first take you through what an income output table look like, and then we can now go back to our question like this. Yes, members, from here, let us put off this first go back and have a recap of the input-output table, how it looks like, and then we shall come back to our question. I think we have finished copy it. Yes. Now, for us to go back into our input-output table, we shall need to just go back and make a small review on what is the input-output table. Members, recall we have our input-output table. Output table. How is it? Remember, we have our input-output table in this format. We have sections of the input-output table. We have sections. I think you recall. Yes, our input-output table is in this format. Here we have, say, industries. We have industries A, B, C up to D, up to D. Like that's an example of that. Then you have A, B, C, and then D. Then here you have a section for final demand. And then here you have a section for gross output. Yes, therefore, the whole of this area is called intermediate input. The whole of this region is called final demand. And the whole of this area is called gross output. Now, the whole of this area, remember here you have imports, and then here you have salaries and stock wages. Here you have salaries, wages, you have rent and profit, like that. Therefore, here we call this intermediate imports. And then here we call here factor payments. These are factor payments. Now, we recall that from our definitions of, now let us first have the definition of domestic product, DP, domestic product. We have also DI, domestic income. And then lastly, value added. From this input-output table, we get to know that all the domestic income, domestic product, and value added are all the same, in a way that if I have domestic product, domestic income, and value added, all give us the same answer. But we know that first we get the domestic product, I just need to find the final demand minus the value of intermediate inputs. This is final demand minus value of intermediate inputs. What now domestic income? Domestic income, we know that domestic income is equating to the factor payments, the sum of factor payments, or total factor payments. Just from this table, we have likewise what? Now for the value added just simple. We just need to have the gross output minus, yes, gross output minus what? Is gross output minus now value of value of intermediate consumption of intermediate consumption. But value of intermediate consumption is composed of two things: intermediate inputs and intermediate inputs. You have intermediate inputs and intermediate imports. Just like that, the gross output minus the value of intermediate input and intermediate output. We know that the dP and di and the value Va are all the same. But right today, according to our question, we won't be going mean for this. I wanted us to just have this, and then now we go ahead to find the coefficient matrix and likewise these are terms that we're going to look at, the inverse and the coefficient matrix. Now, members, let us take a case. Let us now subdivide our remember from this okay, let's have it in a simpler, in the way we want it now. Now remember, if I have let us take a case now. We have we have our industries. We have industry A. Yes, we have B. Then we have C. Remember, we have A here again, B, and then C. Yes, B and C. And then here you have final demand. Then here you have gross output. In that way. Recall that we shall always, in order for us to have gross output, in order for us to get gross output, we need to add intermediate inputs plus final demand equals to gross output. Now, if industry A produces output A, therefore, part of the output A is going to be consumed by A itself. Let us call it A11. This total output A is going to be consumed also by B, we call it A12. And then this total output is going to be consumed by C, we call it A13. And then there is now the remainder is going to be called the final demand for A. Final demand for A. Like that. Likewise, if B is going to produce B units of gross output, part of it is going to be consumed by A, that's called A21. Part of this is going to be consumed by B, call it A22. And then part of it is going to be consumed by C, we call it A23. And then here we have final demand for B. Yes, in order for us to have the gross output B. Likewise, if C produces gross output C, here we have A31 consumed by A, part of C consumed by A. Now A32, part of C consumed by B, and then A33, part of C consumed by C, which is then plus now F final demand for C. Now from this table we get to know that this is this A1, A2, A3, A4, A5, A6, sorry, A11, A21, all the whole of this matrix gives us a picture of the coefficient matrix. But now from here, I want to show something interesting. We know that if we add the gross output, the intermediate inputs plus the final demand, we get the gross output. Now from here, let us just have something like this. Remember, for A, for the whole of A has to be consumed by A, B, and C, and then final demand. Therefore, for me to get what is contained in A, therefore I say from I have that my A, part of it is going to be consumed by A. I have A11, A. Now, part of it is going to be consumed by B plus A2, A12, B plus part of it is going to be consumed by C, A13, C, like this. Now plus the final demand for A. Yes. Now if I make FDA the subject, I just bring this one this side, all of them. Now if I bring A and this A11 this side, if I hold that term, I have something like 1 minus A11 into A, now minus A12 B minus A13 C equals to FD A. And then this is our equation 1. Likewise, we do the same for B and C and D. Now for B, the whole of B is going to be consumed by A, B, C, and then final demand. Therefore, the part of B, this B is going to be part of it is also be consumed by A. I'll have A21 A plus A22 consumed by B, then A plus A23 consumed by C, then plus the final demand for B. Something like that. Now, if I bring this, if I make FD the subject, like I want FD this side, I'm just bring this on this side here. I'll have now negative A21A plus, because I have a B here and then this becomes this side, I have now 1 minus A22B, something like that. So the B is going to be outside here. Now minus, so it's coming this side, minus A23C equals to FDB, equation 2. Likewise, now I do so for C. This is coming this side. Like the whole of C goes out of this one. It's going to be consumed by A, B, and C, and then final demand. Then I'll have my C equals to A31 consumed by A plus A32 consumed by B plus A33 consumed by C, then plus the final demand for C. FDC like that. Then if I bring this one inside to make FDC the subject, I'll have something like I'll have negative A2 A31 A minus A32B, now plus, because I have a C here, 1 minus A33C equals to FDC. Now from all these equations we've had, I can extract my matrix, which is easily seen by everyone, that from this I can have my matrix like this. I have 1 minus A11 minus A12 minus A13. Yes, here I have something like, from this equation here, I'll have my equation like negative A21 into, here I have 1 minus, this is into 1 minus A22, and then here I have minus A23. Yes, from this equation here. Then in this equation I'm going to have minus A31. Here I have minus A32. Then here I have 1 minus A33, something like this, times I have my A, B, and C equals the final demand matrix, which is FDA, FDB, and then FDC. I think, members, we are together on how I've got this matrix here. Because if I do row by column, I get these equations. Like question 1, I get it by saying this one times A plus this one times B plus this times C equals to FDA. And then I'm using these equations to get that thing back. Likewise, allow me to make you understand that also this can be got from, this one is got from something like this. I have 1, 1, 1, then I have a 0, 0, 0, 0, 0, 0. Minus A11, A12, A13, A21, A22, A23, A31, A32, A33. The whole of this, if I multiply it by AB and C, I'll be able to get the final demand matrix, FDA, FDB, and FDC. Yes, members, are we together? Like I am saying that here, it's just matter of getting 1 minus A11, which is here. 0 minus A12 is negative this. And then like this. Therefore, from here, I want to conclude that this is the same as having, I'm saying that this is my identity matrix I. This is my A matrix, which I had already here. My A matrix, something like this, A minus I. Then this is our gross output matrix, yes, equals to our final demand matrix. Members, are we there? On the same page, that I minus A times the gross output equals the final demand. That's from this expression, we are from doing everything here from doing. I think we are okay. Now from there, I just get to something interesting, that in order for me to get gross output, when I have my A is, remember, is the technology, I minus A is the technology. I just need to say if I have I minus A times the gross output as the vector equals to FD, which is the vector also for which is the matrix for final demand. In order for me to take this side, I just multiply times the inverse. Therefore, if I have A minus A, I minus A times I minus A inverse gross output, the same as having I minus A inverse times the final demand. Therefore, my gross output matrix is got from I minus A inverse times final demand times the final demand. And then this is what we need to apply to our question. Yes, members, I think from here, everything is interesting. Now I get to know that this I minus A is my inverse coefficient matrix. And then this A, our matrix A, is the coefficient matrix. Now, what is the significance of this inverse coefficient matrix? What is the significance of the A matrix? We said this A11, it means that out of the whole gross output produced by factory A, part of it, A11, is used by A itself. Therefore, this shows us a direct effect. But if now we are talking about now this I minus A1, this I minus A1 shows us part of the gross output that is consumed by a factory itself, the leading diagonal elements. That's what will be showing us. And then this inverse shows us the both direct and indirect effect. Yes, members, I think now we can go ahead and now talk about our question we had on the board first. Yes, members, I think we're together. This is just a takeaway we need to, because we're going to work out with this equation here, solve our equation. Now, members, let us go ahead. Yes, if we go ahead, just now to solve our question, shall have something interesting. As you've seen our question that is interesting, then we shall just need to complete it and see the solutions now. Yes. Now, let us go back to our question. Our question in part A was saying, identify, state the key underlying assumptions of the input-output table. Now, for the assumptions, underlying the input-output system, input-output analysis. One of it, we say that the input requirements are, we say the input requirements are proportional to the output. One of it is saying input requirement is proportional to the output. Like what you input is proportional to what you get. Like whatever you input is directly proportional to what you output. Yes, if you put in less, then you get less. If you put in more, you get more. That's the first assumption we assume. The second one, we assume that there is constant returns to scale. There is constant returns to scale, meaning what? Meaning that if I double my input, therefore my output has to double. That's the constant return to scale. If I double it by 2, if I double my inputs by 2, output also has to double by 2. I think that also makes sense. And I think the last reason is that you have the homogeneous output. Firms have homogeneous output. This means that every firm has a single and a unique and a uniform output. Like each firm is producing one commodity which is single and unique. Okay. Now for that part is understandable. Let us now understandable. Now let us go now for the part Roman 2, which was telling us about the inverse coefficient matrix. They said below the table of the inverse coefficient matrix, they gave it to us. I think you've also seen it. I've written it down, but let me repeat it. It is something like for us to see it properly. It said it is what it has see it again. Just bear with me for some time. It is 1.0255 0.3398, and then 0.1775, and then 0.6913. Then you have here 0.1885. Then here you have 1.3550, and then here you have 0.0258. Then here you have 0.2808. Here you have 0.2521. Then here you have 0.2745. Then here you have 1.1251, and then 0.3878. Then lastly, you have 0.8977, you have 0.2125, and then 0.1105, and then 1.3346. Something like this. They told us that is our input. That is our that is our inverse coefficient matrix, our I minus A. We are given I minus A inverse. This is it. Now they told us to give the meaning. Say, give the logical meaning of each of the leading diagonal elements. They told us to give the meaning of each of the leading diagonal elements. This, and this. Now, I'm going to give a summary. Now, these diagonal elements, both total and direct, total, meaning direct and indirect impact of the output required to produce 1 unit of the output from each sector itself. I'm saying each of the diagonal elements here show these values, I'm saying these values show the total direct and indirect impact or effect on output required to produce, or on inputs, on inputs required to produce 1 unit of output, required to produce 1 unit of output by output for each sector itself. I'm saying these values, these diagonal values, this and this, they show the total direct and indirect effect on inputs. I'm saying inputs required to produce 1 unit of output for each sector itself. Like if this is say agriculture, what I will need this to produce 1 unit of each output itself. Like out of the total output is going to produce, it needs this fraction of total output produce itself. And therefore, from that, we get to know that the bigger this value, the bigger the value, it shows that the sector is self-dependent. It shows that the bigger the value shows that the sector is self-dependent. It means that if this value is bigger, it means that bigger than the rest of these values, shows that this sector depends, like consumes more of its output as inputs, like it uses most of its output as inputs rather than other sources of inputs from other sectors or industries. Are we together? Like let us take an example. If we're talking about agriculture, and the farm is producing, and the farm, like a farm, say a farm is producing 100 bags of maize. Now, if this value, the reading the diagonal value is bigger, say it is bigger than all these other values, it means that out of the total output produced, our question uses most of its inputs from itself. Like we may, if our question requires 100, requires 10 bags of like 10 units of an equipment of input, therefore it uses most of it from itself. Therefore, it is self-dependent. The sector is self-dependent. Now I think I've tried to explain that part. Now let's go to the part of calculations. Now they said, they said, let us put off this again. Now for this part, they said if the sector final expenditure budgets are, now they give us final demand. They give us final demand equals to, they said, first of all, it is 1,200, 1,350, and then 500, and then 850. They gave us final demand. They want us to find, yes, they are saying compute the respective output levels. Not just find gross output, but remember gross output, as from seeing, the same as having I minus A inverse times the final demand. Now we have the final demand is here. We have the inverse coefficient matrix, which is this one. Now what I need to know is I just need to multiply this, the final demand here, to get the gross output. If I just say gross output equals to this, then I have the inverse matrix, which is I minus A, times the final demand, which is 1,200, 1,350, 500, and then 850. Then from here, I'll get my gross output, which is going to be 4 by 1. Now, members, let us do it together from press the calculator and let us do it together with the calculators. For I already have my answer, but I want also to give you time and get the answers. Now, let us try and do it together. We can just feed into this matrix into our calculator and then multiply directly with the calculator, or you may use row by column. You say this time was this, plus this time was this, plus this time was this, plus this time was this. Everything gives you the right answer. Now let us go ahead and we see how we can do it. Now for my, I am putting 1.0255, have 0.1885, and then here I have 0.25, yes, 21. Then here I have 0.8977. Here I have 0.3398, sorry, 98, yes. Then here I have 1.3550, and then plus here, sorry. Then here I have 0.2745. Then here I have 0.2125, and then here I have 0. Sorry members, sorry. I want to input a 4 by 4 matrix I had inserted and the 4 by 4. Yes. You can come back again. 1.0255. Then you have 0.3398. You have 0.7, 0.1775, and then here I have 0.6913. Then you have 0.1885, and then here you have 1.3550. Then here I have 0.0258. Then here I have 0.2808. Then here I have 0.2521, 0.2745. Sorry. I have 0.2521. Then here I have 0.2745. Here I have 1.1251. And then here I have 0.3878. Likewise, there I have What do I have? I have 0.8 977. Here I have 0.2125. Then there I have 0.1105. Here I have 1.3346. And then I think now I need to multiply times shift 4. I also input now a 4 by 1. Sorry, 4 by 1, which is 1200, then 1350, then 500, and then 850. Then from here I have my answers 1 3. Yes, I think I have the same. I had the same calculations. Yes, it is okay. It is okay. Yes, let's proofreading my answers. Now from here I get to know that my answer is going to be as I just multiply, row by column, row by column. I have my answer as I have 2 3 4 74.17. Then I have 255 4.885. Then I have 904.305, and then lastly I have 2536.95, and that is my solution of my final output. And then I'll be able to answer that is the final output for each sector. Then the other question I was talking about, the Roman 3 as we conclude. Remember, as I think, let us conclude with this Roman 2. They are saying, suppose, the question is saying, suppose, they're saying, then if there's any increase in the sector in 2 Roman 2 by 20%, not as find out, there's 20% increase in, then there is also 30%, and then there is likewise 50%, and then 10% in the final demand. This is the final budget, something. Now, therefore, our budget has increased now, has changed from this to a new. Therefore, we need to find the new budget. Now, how do we go for this? Just go for this in the way that we just said, like 100 plus 20% times this value. You shall have now 1.2 times this, we get the answer. Therefore, if you have that answer, therefore, new final demand is going to be something like final demand. If I have 1.2, like 100 plus 100% plus 20% times 1 times this, I will have 1440. Then 100%, 1.3 times this, I will have 175, and then 750, and then lastly 935. This is going to be my annual demand by increasing that. Now I want to see how does this have an effect on the final demand. Now what I'm going to do is, again, I want to multiply this now times this, not this, to get our final new demand, our final new gross output. Now let us do it again. I'm multiplying this, the inverse matrix times the new demand. We get to see what we get as our answer there. Now let us do it with ease. Yes, let us do it with ease. Now let me just change here. I have 1440. Then here I have 1755. Then here I have 750. And then here I have 935. Yes. Then my final demand is going to be something like 2. Here I have 2835.962. Then here I have 3271.8995, and then 1248.0215, and then lastly I have 3026.977. Something like that. I think it is the same thing I have also. Yes, now this is the new final demand. This is the new final gross output. New final gross output as a result of increase in the final demand. But now the question wants us to find the change in final demand. The question wants us to find, compute the changes in output levels respectively. Now, for changes in output levels, we just need to have this minus this to get the answer here. Therefore, the changes in final output respectively we shall have. Now, changes in final output, changes in output is going to be just the difference between this and this, because this is our new, this is our old. Now, new minus old, we get the change. Now, our change is going to be just simply 461.792. Yes, now I have 717.0145, and then lastly we shall have 1248.0215, and then lastly we shall have 3026.977, and then this is going to be our change, yes, it's going to be the change in output as we have seen. Members, I think for today, let us go with this as we see, as we shall have more videos about national accounting, as you have seen that we have tried. Now we are trying now to see how we can go there, do our best. Members, before we go, allow me to thank you for watching our videos, always subscribing and sharing. Members, keep me involved by asking questions in the comment section. I'll be able to answer, and then comment next which area should I go in for. Members, I think you are enjoying. This is Math in Motion, and Shakano is your math tutor. Members, keep liking, share, and subscribe for the videos. I will be happy and grateful. Thank you for watching. I remain Shakano, the math tutor. Members, my number is always on, is 0700 98 14 68. For any inquiries and for anyone who wants private coaching, I'm always around. I also do some economics, although some videos are coming for economics. I'm partially a math tutor, but I'm now going in for economics. Just know, have to be, this world needs diversity. Have to be diverse. Thank you for watching, and this is your math tutor. I think we have been all right in this discussion. For any questions, feel free to comment in the comment section. I will be able to answer your questions, or WhatsApp me. I will be able to answer you. Thank you for watching.